In this problem, what we're doing is using the p-hat distribution. And we start off by being told that this polling agency reported that the proportion of 12th grade students who are engaged is 0.34. Now that 0.34 is our value of p. That's the probability of success, or the proportion of successes in the population. The engagement is defined as students' involvement and enthusiasm with school. The superintendent of one high school district believes the engagement of her students is higher than the proportion reported. So she surveys 90 of the 3,600 students in the district. So this is the number in the survey, and finds that 38 reported being engaged in school. And then we're asked to complete. So first of all, we're asked what type of variable this is, and it is qualitative because you're asking people to rate their engagement. And then the second part is, what's the sample proportion? Well, to find the sample proportion, we're going to look at the number of people who are engaged, 38, out of the number in the sample. And the number in the sample was 90. So that's where this value comes from, this 0.4222. And then we have two tests to see if a proportion is approximately normal. And the two tests are, first of all, the sample size has got to be less than 5% of the population size. This is just a fact. Okay, so we just check that out to see. And the sample size here is 90, and 5% of the population size is 180. So that's fine. And then the second part is we need to check n times p hat times 1 minus p hat, which is q hat. Is that greater than or equal to 10? Well, n is the number in the sample size. P hat is that proportion that we have up here, 0.4222. And q hat is 1 minus p hat, so that's 0.5, let's see, 778. And we multiply that together, and we find out that that's equal to about 22, which is definitely greater than or equal to 10. That's our second test. So we've got to perform those two tests first before we can say that we can use a normal distribution. Now, once we do that, we know in this normal distribution that the mean of the distribution is the same. The mean for p hat is the same as the mean for the population. Okay, so that was given up here at the very top. So mu sub p hat is equal to 0.3400. The rest of this didn't show up. So sigma, the standard deviation of p hat, and that distribution is another little formula. It's the square root of p times q divided by n. So now notice, this is not saying p hat, it's p and q. So we're multiplying 0.34 times 0.66 and then we're dividing that by the sample size, which in this case is still 90. And that's where we get our answer for our standard deviation. Okay, that's the next part of that problem. Let me stop here. Okay, so continuing on, we were multiplying 0.34 times 0.66, dividing it by 90, and taking the square root. And so that answer ends up being this value right here, the 0.0499. Then the next question says, what's the probability p hat is greater than or equal to 0.4222? Okay, so that was the 38 out of 90 students. And so for this, we're going to use the stat crunch. And in stat crunch, we want to use for our mean the 0.34. And for our standard deviation, we're going to use that last answer that we've got up here, the standard deviation for the p-hat distribution. 0.0499. We're going to go to Stat Crunch, Stat Calculator, and choose the normal calculator. And with the normal calculator, we're looking for what is the probability that x is greater than or equal to 0.422. Okay, so we're punching that in for the expression, and these two values are our mean and standard deviation. So that gives us this answer, the 0.050. Then we're supposed to be interpreting what this probability means. So what this is saying is if we took 100 different random samples of 90 students out of that 3,600 students in the district, we would expect 5%, and 5% of 100 is 5. So we would expect 5 to have at least 35 students that are engaged. I hope this helps.